So lesson 41, we're going to add like terms in rational expressions, which when we see rational expressions, typically what you should think of is fractions. That's what we mean by rational expressions, all right? It's basically any value that can be expressed as a number over a number in a fraction. So technically this is a rational number because we could express that as 3 over 1, right? But usually when you see rational something or another in the text, we're dealing with fractions, all right? So for this one here, we need to add like terms. And so sometimes the way the problem is presented to you, it's not always obvious that you're actually dealing with like terms. So you're going to have to do some, you're going to have to manipulate the variables some before you realize, oh, I didn't know those were like terms, but they actually are. So let's look at that. Minus 3 by squared x to the negative 2 plus 4y squared over b to the negative 1 x squared. All right. So when you see a problem like this, again, you should always be thinking when you see anything with variables in it like this, like if I see something like 2ax plus 3b minus 4xa. When I'm seeing something like that, I'm immediately thinking, all right, are there any terms that I can combine, right? And so I'm thinking like terms. Are there any like terms? And I'm looking at this. What do I mean by like terms? Let's make sure we understand that definition.
Same variable.
Has the same variables, the same exact variables to the same power. It's got to be exactly the same, right? Now they may be out of order, but they have to be the same variables with the same power. And sure enough, we see here that if I rearrange the order, this is why I like to rewrite my variables in alphabetical order. It becomes very clear that this and these are like terms, right? So I can add those together, and when I add them together, I'm basically just adding the exponents. I'm saying 2 minus 4, not exponents, I'm sorry, I'm just adding the coefficients, just the numbers in front. So I'm saying 2 minus 4, and then I'm following that with the ax, right? Again, this is a step I would never write out. I just do 2 minus 4 in my head, but I'm just writing it out so you can see what I'm doing. And so the answer here would be negative 2ax plus 3b. Does everybody get that? How we combine those like terms? Did I lose you somewhere? Anna, it looks like I'm seeing the, I'm not sure.
I thought you were combining, oh wait, never mind.
I'm combining these two, right?
I see what you
Which
said.
means I'm doing 2 minus 4. Does that make sense?
I was thinking them separately, but I'm
Okay, gotcha.
Okay.
All right, so they have the same variable, so we can combine them. So that's exactly the same thing we're doing here. We're just trying to figure out, do we have any like terms? So when you've got all these negative exponents, my first step would be to make all of the exponents positive. All right, that's what I would do to make sure to see if you're dealing with like terms or not. So in order to make them all positive, what am I going to have to do with my first term here? Which variable is an issue? I know you know it, Liliana. What is it? Which one's the problem?
The one in the middle.
No, right here. If I'm looking just at this term, which variable is an issue based on what we said we were going to do?
The negative.
This one, yeah, the y, right? So we need to move this y to what's that term going to be? What am I doing with my y variable?
Adding it.
I'm moving it to the top. Does everybody see that? Because it's got a negative exponent. I want to get rid of the negative exponent. And so when I'm getting rid of negative exponents, I have to flip it to the other side of the fraction. Does that make sense? Okay. So what would it be? I'm going to keep picking on you. What would it be? What would the new term be?
Bxy to the negative.
Bxy. But we moved this thing up here. So what did we have to do with the exponent?
It'd be positive 2.
Positive 2, exactly, over x cubed. Does everybody see that? I'm just getting rid of my negative exponents. That's my goal with this first step. All right? Who wants to take the second term for me and tell me what it would be? Liam? It's like, oh man. All right, what would this one be? What gets to stay on top?
So it'd be 3by squared x to the negative 2.
But we're bringing that
over
down.
1, and you bring it down.
So we're bringing it down. So this becomes x what?
X to the x squared. Sorry.
X squared, there you go. X to the positive 2 or x squared, right? We just moved it to the other side of the fraction, so the negative value becomes a positive value. And so I won't put anybody on the spot on the last one here. This is 4 b y squared. We move the b up, so the negative 1 becomes a positive 1. And then on the bottom, we have x squared. All right? Now, we can think about this because the number is on the top in the numerator. We can bring all of these numbers out front, and it just makes it a little easier to see what we're doing from as far as the math goes. This is actually minus 3 by squared x squared plus 4 by squared x squared. All right, when we write it like that, it becomes super clear that the exponents, that the variables and their associated exponents are all the same for these terms. Do you guys see that? Every one of these have bxy squared over x cubed. Wait a minute, what did I do wrong? Did I write it down wrong? Or was it only those two? I wrote the first one. Check it out. They made a mistake. So they meant to do this. They meant to do x squared right here. If you see the way that they worked the problem out in the book, they clearly meant for this to be x squared. But they wrote it incorrectly. So I'm about to write in my book and fix that. So you may want to adjust your orders. On page number 165, the way that they list the problem at the beginning on 41.1, where they say bx over x cubed, that should be an x squared. Because they wanted it to work out to where the exponents and the variables and their associated exponents are all the same. Oh, guys, I'm sorry. Sorry. It was x squared. Why was it x squared? My bad. Now I wrote it in pen. That's terrible. Why is this x squared on the bottom? Because we have an x to the 1 on the top. Does everybody see that? We have it's like having x over x times x times x, right? One of those x's cancel out. You guys see that? I'm going to have to write a note of apology to the authors of the book.
So does that mean you remove the x that's on the top then?
So what I should have done right here at the very beginning, I should have been like, this was x cubed. When I went from here down to here, I should have said, oh, this will cancel out with this 3, and that becomes a 2. So then I should have dropped the x from right there.
So
And gone ahead and canceled it out.
if you canceled it out, why is it x to x squared?
That's just x to the square, sorry. This is because I changed it a minute ago based on, yeah, that's what it's supposed to be. Does that make sense?
Yes.
Sorry about that, guys. I should have worked this problem at home first, called that. So does everybody see why this x cancels out with one of the x's on the bottom and it becomes x squared on the bottom? Now does everybody see that we have the same terms, right? They all have the same variables and the same exponents. So we're just taking the big numbers in the front. There's an understood 1 right here. And we're doing the math. 1 minus 3 is what? What's 1 minus 3? Come on.
-2.
-2. -2 plus 4 is?
2.
Positive 2, right? So we have 2 by squared over x squared is our final answer. All right? I'll never doubt the authors of the book again. Yes?
Is the 4 not part of the fraction anymore? I mean, like, it was on the top originally.
Right, so that's what I was saying. Let's think about this, all right? So if I have 4 by squared over x squared, all right? What does that mean with this 4 in the front like that? It's meaning 4 times this value, okay? And so do you see if I do 4 times this value, that 4 over 1 times by squared over x squared is 4by squared over x squared? If I pull the 4 out in the front, it's the same thing. All right, I just wrote it a little differently so it was very clear to us that these are the big numbers that we're adding up to get our final answer. Okay? You could leave it on top and do the same thing and just say 1 minus 3 is -2 plus 4 is positive 2, and so you could have left your 2 up here and said the answer was 2 by squared over x squared. That would be totally acceptable as well. All right?
Okay.
Okay. And that's actually what they did in the book. They left it on top in the book. So we'll leave it on top going forward, but I was really just pulling it out so that you guys saw this is the same thing as having if we had 1x minus 3x plus 4x, right? You guys would look at that and be, that's no problem, that's super simple. It's 1 minus 3 is negative 2 plus 4 is positive 2, and you would say the answer was 2x. That's exactly what this is here. It's just we've got a much more complicated variable over here, okay? All right, let's move on to another one. And again, I won't doubt the authors of the book this time. I'm really sorry, Mr. Saxon. I wonder if he actually wrote this one. John Saxon Jr. says he did. Because I don't think he's still alive. Maybe Senior was the one that started it. Maybe this is his son. All right, simplify by adding like terms. Let's jump ahead to one that's a little more complicated. Let's do 7a negative 3 b squared over c to the negative 1 minus 5b squared over a cubed c to the negative 1 plus 3b squared a cubed over c. We're going to do the exact same thing. We're going to take our negative exponents and move them to the other side of the equation so we can get rid of them. So we're going to have 7. We're going to take the b squared, which has a positive exponent, so it stays the same. We're going to move this c to the negative 1 up and bring that right there. Yep. Yes, you may. And then here we're going to have a to the 3rd power, right? We just flip the side that the variable was on so that we gave it positive exponent. We're going to do the same thing with this one. 5b squared, we'll bring the c to the top, and the a cubed stays on the bottom. And then that last one, did I copy that down wrong? Nope, I didn't. They're trying to trick us on this one. 3b squared. We just have to rewrite that one like it is. You guys see that? Because there are no negative exponents in that one. Yes, Alexa?
How did you get 9 under the 7?
This is an A.
Oh.
Sorry, yeah, that always happens with my A's. There, is that better? Okay. Any other questions? I should totally move away from using A's because that happens so often with me. All right, so now, which terms are like terms?
BC.
That didn't help me. So we have 3 terms. We have term number 1, term number 2, and term number 3. Which two are like, which ones are like terms? All of them? None of them? What?
The 2 last ones.
The 2 last ones?
I mean the bottom part, yeah.
So you're saying this one and this one? Does it have exactly the same variables with the same exponents?
No.
It doesn't. Alexa?
The first 2?
Do you see that the first 2 is the only one that has the same variables with the same exponents, right? So these 2 we can combine, this one we can't. It's going to have to stay like it is, right? So we combine these, so we say 7 minus 5 is 2b squared c over a cubed plus 3b squared over a cubed c. So that would be our final answer for that one. All right, any questions about that? So let's do two-step problems. That's our next example. So this is where they give us something to start with, and we have to solve that one. And then we have to use what we got to actually answer the final question that they're asking us. So if this is true, then what is x minus a? So what are we going to have to do? This should be straightforward enough. How do we solve this two-step problem? I really should have put my book there because I...
-8 where the x is.
Say it again?
Would you plug in the -8 where the x is? Or no?
No, this is what we're trying to find, okay? This is not an equation. This doesn't say x equals 8, right? It's just asking us what is x, whatever the value of x is, minus 8. And so we're going to have to figure out what x is using this equation first. All right, does everybody see that? We're going to use this equation, solve for x, and then we're going to take whatever we get for x and plug it into this. Okay? So x plus 3 equals 7. That's pretty straightforward. What is x? We just subtract 3 from both sides, and we get x equals 4, right? Super simple. We've done that plenty of times. Now that we know what the value of x is, we can plug in x to this, and when they say, what is x minus 8? Well, it's whatever 4 minus 8 is, which equals -4. So that would be our answer for that one. Does that make sense? This should be super simple. You will have some homework problems to practice that, to make sure you get that down if it's a little confusing to you, but I promise you it won't be after you've done a few problems. Remember, doing the problems is how this is going to, so what's going to reinforce this and make this really easy for you to do well on the test and the quiz. I forgot to grab your quizzes. Let me grab your quizzes from you real quick.
You gave me 2.
I gave you 2. Did you do them both? Extra credit? Thank you. Thank you very much. Thank you. All right. So let's see. Let's go to the next section, which is solving multivariable equations. Man, that sounds exciting, doesn't it? No one said, yeah. Why is that? Come on, guys, we're about to get out on Thanksgiving break. You guys should be alert today. Aren't you guys excited? We're about to have a break. I'm excited. I'm going to hopefully get caught up on all my grading and come back after the break with feeling like there's less pressure on me. So, and I'm just thankful. God's good, right? God has. Do you guys realize that this estimated that the average American is in like the top 5% of the world as far as wealth goes? Do you guys realize that we're richer than 95% of the rest of the world? All right. So we have a lot to be thankful for. There's so much that we take for granted that God has just provided for us. And the danger of being richer than everybody else in the world, remember Jesus said it's hard for a rich man to enter the kingdom of heaven. The danger with that is to rely on those riches and trust in those riches instead of giving thanks to the God that in his mercy granted that. And so this is a great time of year. I love Thanksgiving because it's just a day to remind us that we ought to be thankful all the time. 1 Thessalonians 5:18 says, in everything give thanks, because this is the will of God in Christ Jesus for you. So it's just so important and critical that we're thankful all the time. So I love this time of year, and I love the reminder that this particular holiday brings. All right, so here's what we're asked to do. We've got a problem like this, and they tell us to solve for y. Right? So normally, when we're solving for a variable, we only have that one variable in the equation, right? In this particular equation, we've got multiple variables in it, but they're telling us to solve for y. Well, what they want us to do is the same as if they said solve for y if there was only one y variable in there. What they're saying when they say solve for a particular variable is they mean get that variable on one side of the equation all by itself, and everything else has to be on the other side of the equation. Right? Does that make sense? So like when we solved for x plus 2 equals 7, something like that, and I say solve for x, that means I want everything else on this side and I want x on this side all by itself. So we would say x equals 5 would mean that we've solved that equation, right? Because we got x all by itself on one side. So that's what we want to do here if we're solving for y. We want to get y on one side all by itself. So everything that's not a y term, our first step is going to be to move it over, right? Now, if we had parentheses and stuff like that on this side, we'd have to do some simplification in the parentheses first, maybe. but there aren't any parentheses, so we can start with moving everything over. So we're going to have 6y equals, and we're just going to start moving our variables over. 4, we move the x over, it becomes a plus x, and we move the z over, it becomes a minus z. Does everybody see that? We just moved it to the other side of the equation, flip the sign, just like we always do. Is there anybody here that's still getting confused when I do a step like that? Because it's super, super important that you understand that step. If you don't, now is the time today is the day, like the Bible says, today is the day of salvation. Today is the day to get this right, okay? Because it's not going to get any better from here. Yes?
With the 4, since you switched it over from the other equal sign, would you not turn that into a negative?
I didn't move it. See, it was already on the right side of the equal sign. I left it on the right side. So that's the one that I didn't move. Make sense?
What about
Yeah.
the x then? You moved that over.
The x I moved over, it was negative here. I moved it over to the right side, so I had to make it positive, right? The z was positive, so I had to make it negative, right? So remember, what we're actually doing when we do that is, the reason that we can do that is because our rule in algebra is whatever we do to one side of the equation, we have to do it to the other, okay? And so if we want to get rid of this x on this side of the equation, it's a negative x here, so we would add an x to that side. But since we added an x to this side, we have to also add an x to this side, right? And so when I do the math for that, I end up with 6y plus z, right? Because this just turns out to be 0, equals 4 plus x, right? So that got rid of the x on the left side. And then I'm like, I've still got this z here that I want to get rid of. So I would say subtract the z from this side. So whatever I do to one side, I have to do to the other side. And so that gets rid of my z's. And so on this side, I'm just left with 6y equals 4 plus x minus z, which is what I've got right here. That's how I got that. If you still like to think about it like this, if that's the way that helps you think about it, then write that down. That's totally okay, all right? Eventually, this is going to go away. Eventually, you'll do this enough to where you can just jump directly from here to here, all right? I personally think it's easier to just think about, if I'm moving this to the other side, just move it to the other side and flip the sign, all right? But the reason why we're flipping the sign is because we do this step here, okay? That's why that works. So now that we've done this, what would be our last step? What would we normally do if we're trying to get the y all by itself? What would we normally do to get the y by itself?
Divide.
I would divide by what?
6.
I would divide by 6, right? Does everybody see that? That's exactly right. That's what we've always done. Okay? But if I divide by 6 on this side, I have to divide by 6 on the other side, right? Now I have two options. When I've got terms that are separated by pluses and minuses on this side, I can either say I'm going to divide the whole thing by 6 like that, or I can divide each individual term by 6. Divided by 6, divided by 6, divided by 6. Okay? Either way would be correct. I'm going to do it like this because that's going to give me the opportunity to simplify the 4 over 6. Okay? So these 6's cancel out, so I'm left with y equals 4 over 6 simplifies to 2 over 3, right? Plus x over 6 minus z over 6. And that would be our final answer. Okay? You guys good with that? So let's do another problem that's similar, but this time we're going to have the y variable on both sides of the equation. So we have 4x minus 2y plus 2 equals y minus 4. All right? Now I'm just going to say this again. I'm going to keep harping on this. You're probably already sick of hearing me say it, but I'm going to keep saying it because I keep grading your tests and your quizzes, and some of you guys aren't listening. All right? You have got to work these problems, and you've got to work multiple problems if you don't understand it. And keep working problems until you get this process down. This is memorization. That's all it is. Right? It's just you look at a problem and you've done enough of those problems that you've memorized how you tackle that problem. So when you're working these in your homework, take your time. It's not about just making sure I get my homework done so that I can turn it in and get the grade. It's not what it's about. It's about making sure that you understand it. That's why we assign the homework, right? Because again, like I've told you guys, you're going to use this stuff over and over and over again moving forward in math and science. It's going to pop up everywhere. It's going to pop up in real life, right? You may not think it, but there are places where this is going to creep into real life. I was talking to a guy yesterday when I went and got the emissions done on my car, and it was simple math stuff, and he couldn't do the simple math. He had asked me, had he done the simple math right, so that he charged me correctly. Okay? That's what we're talking about here. This is the simple stuff. This is the basics. And it's not going away, so you've got to take the time now to get it down. It's just going to make your academic career harder from this point on if you don't get this down. And so if you're working a problem and you don't really understand it, you had to go back and review the solution. Do an extra problem that's not assigned. Do extra problems until you get this down, okay? Until it becomes automatic. Let me grab my calculators before I forget about them. I've got 4 of them out there somewhere. Thank you. Thank you very much. So, we're solving for y, all right? The directions are the same, solve for y. What is the process? We want to,
Get y.
what time does this class get done?
11:10.
Huh?
11:10.
Like 2 minutes, right? 1 minute? Okay, just making sure. We want to get y by itself, which means we want to get all the y's on one side, right? And everything that's not a y on the other side. Does everybody see that? So here's what we're going to do. I just like to have my variables on the left side. You don't have to. Sometimes I'll put them on the right just so I keep them positive, but in this case we won't. We'll leave it on the left. So we're going to leave this negative 2y here, okay, on the left side. But we're going to bring this y over. So if I bring it over to the other side of the equal sign, it's got to become a negative y. Does everybody see that? And everything else I'm going to move over to the other side. So my 4x is going to go over here. So I'll leave my y minus 4. I'm sorry. I move that y over. I'll leave my minus 4, my negative 4 here. I'm going to move the 4x over, so I've got negative 4x, right? And I'm going to move this 2 over, so I've got negative 2. I just moved them over to the other side and flipped the sign. I moved this y over here, so I moved it over and it became negative y. And then I moved the 4x over here, it became negative 4x, and I moved the 2 over and it became negative 2. All right, so let's simplify and do the math. This becomes negative 3y equals negative 4 minus 2 is negative 6 minus 4x. Right? Everybody see that? And then I want to get the y by itself, so my last step is I'm going to divide every term by negative 3. All right? So my 3's cancel out there, and I'm left with y equals positive 2, because negative 6 divided by negative 3 is a positive 2. A negative 4 divided by negative 3 is going to be a positive 3, so positive 4/3 x would be my final answer for that one. All right? So, it's Thanksgiving. You guys only have 2 lessons to do homework for, so you got something to be thankful for right there. Not as much homework, right? So when we get back from the break, Lord willing, we will have a quiz over lesson 40, lesson 41, and lesson 42, and then the following week we'll take the test for it. Okay? You guys have a great day and happy Thanksgiving.